Hello everyone, this is Deep Patange. Today I'm here to give a demo lecture for data science trainer job profile. Our topic which I chose today is linear regression, and over the next few minutes we'll explore the concept, math, understand it with the graphs, and implement it in Python. Talking about myself, I'm currently working as a research analyst at media.net. I've done my bachelor's in artificial intelligence and data science, honors in blockchain. Currently, I'm pursuing my master's in computer science. Here's a roadmap of today's session. We will start with a quick introduction to machine learning and see where linear regression fits in. Then we will break down the concept, cover the math, visualize it with the graphs, and finally implement it in Python. We will wrap up with some real-world applications and a short recap. Moving ahead with machine learning introduction. To understand machine learning, let's warm up with a simple example. Imagine I show many pictures of cats and dogs to a boy. He will recognize them after enough examples. Your brain starts to identify them automatically. Now, if I gave him completely new picture which he have never seen before, his brain can still identify whether it's a cat or a dog. In our scenario, it's a dog. This is exactly what machine learning does. It learns from the examples and then predict the unseen data. Now the same idea works for numbers also. Suppose we have data of houses which have size in square feet and prices or selling price of that particular house. Now if we give this particular data to a model, the model learns the relationship between size and price. Now if I give him a new house which have a new size, then it will predict the selling price of that particular house. So these three are the main concept or main steps of machine learning. Input data, which contains historical examples, or live stream data, which we feed to the model. Model training, where the algorithm learns the pattern from the data. And output, where the model gives us the answer for new unseen data. Let's move ahead with the machine learning types. So we have different types of machine learning. Supervised, which use labeled data. Then there's unsupervised with unlabeled data. Semi-supervised with a mix of labeled and unlabeled data. And reinforcement learning with learning through rewards and penalties. Moving ahead, in this diagram, we can see that there are different types of machine learnings. Supervised machine learning, where model is trained with labeled data. Under these, we have classification, which predict categories. And then we have regression, which predict continuous values. In the middle, we have unsupervised learning, which works with unlabeled data. A common task here is clustering data with the similar data points are grouped together. Then on right, we have reinforcement learning, where model interacts with environment and take action, receives feedbacks and learn to improve the performance over the time. For today's lecture, we will be focusing towards supervised learning, specifically on the regression part. And we will learn one of the most important regression technique, which is linear regression. Now you know exactly where linear regression fits in machine learning. Moving ahead, let's try to understand supervised learning. The diagram here represents supervised machine learning. We start with the labeled data here. In this example, we have tomatoes, carrots, bell peppers, and each one is already correctly labeled here. We feed this labeled data into a model, and during the model training, the algorithm learns the patterns and differentiate them in each different vegetable according to its shape, size, and color. Once the model is trained, we give it to new data. So if I introduce new data to this particular model, it can still predict whether it's a carrot, a bell pepper, or a tomato. The model then predicts correct label based on the learned earlier data. This is the essence of supervised learning, training with the labeled data so that the model can predict predictions of a new output. Let's talk about linear regression. So we have done machine learning introduction. We have also done supervised learning. Now let's deep dive into linear regression. Linear regression is one of the most fundamental algorithm in machine learning and statistics. It's a method used to predict a continuous value by finding relationship between one or more independent variables. The relationship is represented as a straight line, and the equation of that straight line is y is equal to mx plus c. Key points here to understand that linear regression predicts numbers, not categories, and it works best with the linear relationship data. Examples of linear regression are predicting house prices from a size, estimating marks from study hours, forecasting sales from advertising spends. So let's understand the equation of a line of a linear regression. So we have equation as y is equal to mx plus b, where y is your output. Right? In some books, it's also written as f of x, where x is input, your m is slope, and b is intercept. It can also be written as y is equal to beta 1 x plus beta 0, where beta 1 is slope, x is your input, and beta 0 is your intercept. Okay, let's see how the linear regression line is chosen. We start with our data points. Each one is showing the actual size of a house and its price. The model draw a line to take a prediction. So this is your best fit line. These are your actual points, right? So what we do, we draw a straight line from an actual point to a best fit line to understand what's the error in between them. This error or this distance between the actual point and the prediction line or best fit line is called as residual error. What we do here is we try to sum these square errors. And if the slope is too steep or too flat, the SSE becomes large, and we adjust the slope and the intercept of SSE change. So here you can see we are doing square of this error. Squares are getting increased, as you can see in the video there. Okay, so what we are doing, we are adding these squares, and then we combinedly call this as a sum of square errors. So now you understand that for making a best fit line, you need to minimize this SSE, which is sum of square errors. So this making this best fit line is done using linear regression. So let's try to understand this with an example. So here I have taken square feet and house price. So we have like 1,300 square feet area, and its house price is 2,40,000. So let's try to understand how exactly this can be represented on a graph. Here you can see the dependent variable here is house prices, which is written at y, and independent variable here is square feet. So we can have multiple independent variables, and this is how a best fit line is drawn over here. Here are the actual data points you can see, and this is the linear regression line. Y is equal to mx plus c, or like c, you can write in different formats also. The gap between the actual predicted point and the actual point is called as residual error. So this is how exactly you put or you make a linear regression graph. So now we have covered machine learning, supervised learning. We have understood the mathematical foundation of linear regression, graphical implementation of linear regression. Now we are going to implement linear regression with Python. We are going to import libraries, then train a model, then we will calculate the accuracy. We'll try to visualize the model and predict new values. For importing libraries and create data set, we need to import Pandas. Then we'll try to import NumPy and Matplotlib as plot. And from Scikit-learn, we will be importing linear regression and R2Score. We use Pandas for handling the data in table format. NumPy we use for numerical calculations, and Matplotlib is used for visualizing results and all. Scikit-learn is here, like we have imported Scikit-learn so that we can import linear regression from it. And Scikit-learn matrices so that we can understand how to score the accuracy of this particular model. Step 2, we have created data. So as we've seen earlier that this is what we have taken as a data. This is a sample data. So I've converted this data into a data set, and then I've converted the data into a data frame. Cool. Moving ahead, I've put our we have split the data into X and Y. So X, we have put square feet, and on Y we have put house pricing. So these is features we are putting in X and Y. Create and train model. So we are calling our model, which is linear regression. Then we try to fit that model to the data, and ypred is your to make predictions of that particular model. So let's try to understand what is the accuracy of our model. The slope, which we know m, is 131.31 here. Then intercept is 9744, which we are getting. R2 score, the accuracy here is 0.61. So the more it's closer to 1, it's more accurate, and more it's closer to 0, it's less accurate. So it's 0.61, which actually means 0.7, which is good as we have taken a dummy data. And our SSE, residual sum of squares, which is this much. Cool. So we can just calculate this R2 score by using these functions which we pulled already from Scikit-learn matrices. Okay, and then we try to understand residual error, total variations, and all these things. Moving ahead, let's try to visualize the model. Okay, so let's try to understand our machine learning model or graph. So this is the linear regression house price prediction graph, which of our data which we have provided to our model. So these are our house prices. This is square feet, and 1400 square feet, 1600 square feet, and these are your prices. So you can see the actual data points here, and this is your regression line or best fit line. This is the prediction page where we will get the prediction for our input. So as an input, we have given him like a square foot area of 1600, and we got output as predicted price for 1600 square feet is 3,852,000 rupees. So this is how your machine learning model can use to predict the price of house using square feet or using area of that particular house. Let's talk about applications. Linear regression can be used for various applications, but most famous of them are forecasting temperature changes, predicting crop yield from rainfall, estimating employee salaries from years of experience. These are few examples. There are lots and lots of applications where linear regression is used nowadays. I think I've explored all the important topics related to linear regression. Let's do a short recap. We tried to understand machine learning earlier, and then we moved towards type of machine learnings, supervised, unsupervised, and reinforcement and all. And then we deep dive into what is supervised. It uses label data and all. And then moving ahead, we deep dived into linear regression. We tried to understand what is residual error. We tried to understand what is best fit line. Then how the line is drawn, what are intercept, what is slope. We have covered all these points. And then at last, we tried to implement it with the code. And in code, we have tried to understand what its accuracy is. We got 0.67 accuracy. We got prediction as price. We have given input as size, right? So this is how linear regression works. I hope you found this video useful. I hope I made everything clear. Thank you for the opportunity. Thank you everyone. Take care. Goodbye.